today I thought we'd have a look at your new science magazine. We'll just choose a feature to look at. And we can practice scanning the pages and turning the pages. So, okay, let's have a look at some of the headlines. Anything that grabs your attention? We've got easiest, quickest ways to get healthy with Michael Mosley. Ooh. BBC, the mysterious rumbling waking up Mars. Surviving the next giant leap. How we'll break through our biological limits to colonise space. Are microplastics harmful? The tech-fusing mind and machine. Can you change your personality? Oh, well, do any of those grab your attention? Oh, that one. How we'll break through our biological limits to colonise space. I like that. How we will break through biological limits to colonise, oh, excuse me, space. Let's just see how your pointing is today and do the word space. Space. S, P, all the way up, up, A, S, P, A, C, and after the C, always finish it. Very nice, space. Now then, what sort of problems do you think, before we even look at the article, what sort of problems do you think there might be? What are our biological problems that make it difficult for us to colonise space? I know that you know this because we've already, discussed things like this in the past. What sort of things would make it difficult for us to colonise space? We'll take it in turns. You can say one thing and I'll try and think of something as well. What might make it difficult? L, A, C, K, lack, that's good. Lack. Oh yes, I did. Sorry. Lack. Go on. Lack. O. Of. Lack of. O. Oh yes. X. Y. G. Okay. After the G. E. And finish the word. N. Lack of oxygen. That would make a problem, wouldn't it? Lack of oxygen. And then in terms of biological limits, what else could there be? I know that didn't they find in studies that when spacemen stayed up in space for a long time, that they started to sort of lose bone mass and things like that. So that was a problem. Let's have a look and see what finds out. So how we'll break through our biological limits to colonise space. Let's see if we can find the article. Oh look, I think it's in this features, so you have a look You have a look. Quite small, the print, and see if you can find which article we should look at to find the answers to that question. Is it on page 46, 54, 66 or 72? Which one? Excellent! 66. Through hardship to the stars. Page 66. Professor Christopher Mason, who studies astronauts' reactions to life in space, reveals how we might adapt to a life among the stars. Right, so now we need to look at the bottom here. See the page numbers, that's page 5, so we need to go right the way to page 66. Would you help and turn some of the pages over? Come on, turn over, turn it over. You can do a few at a time, just practicing. Turn those over. And look, we're at page 25 now. Turn a few more over, we wanted page 66. There, oh here we are, there's 61, 2, 4, 66. And on the first page we've got a picture of an astronaut, Commander Scott Kelly, shortly after touching down in Kazakhstan in March 2016, almost, listen to this, almost 1 year after he'd been on this International Space Station for 1 year. And look what it says, in small print. He was 5 centimetres taller than when he left. So, 1 year on the space station. What happened? H, he, G, yes, go on. R, E, he grew, how many centimetres? 5 centimetres, yes. He grew 5 centimetres. Let's read it. This print is a bit small for you, but so I can read it and we can discuss the key points. So, when Scott Kelly came back to Earth after 340 days in space, it felt like his skin was on fire. Ooh, skin on fire. I wonder why? Not on re-entry, but later when he tried to sit down, get dressed or moved. Sit down, get dressed or move. Spending close to a year in microgravity will do that to you. Kelly's skin got used to feeling no weight and having nothing touching it. So he'd got used to no weight, nothing touching it. Because he was in microgravity. So what was the problem he experienced? S, K, I, skin, F, E, F-E, go on, L, skin felt, O, on, you're there, go on, F, there's the I, you push your finger to it, I, there's the R, and all the way up for the E, skin felt on fire, skin, oh, hand down, felt on, oh my gosh, I don't think I'd like that bit, his skin felt on fire whenever he tried to move, sit down, get dressed or whatever. So listen. Like other astronauts, he floated around the space station with little need for furniture. He didn't wear shoes, and even his clothes drifted around his body instead of hanging from it. So if you imagine, so his clothes kind of drifted on his body. If you imagine your t-shirt now, instead of resting on your skin, because it's slightly big, it would just kind of float around your skin, and there wouldn't even be the weight of the clothing on your skin. So when he came home, a shirt sleeve bearing down on his arm like this, under the pull of Earth's gravity, was like painful. As he said in a post-flight press conference, adjusting to space is easier than adjusting to Earth. Oh, adjusting to space easier than adjusting to Earth. So what was his experience with his clothes? T-H-E-Y, they. Was that D or E? It was in the middle. D. D. Next letter would be R. I, then after the I would be F, T, E, they drifted, A, R, and after the R, go on, keep it moving, keep it going. O, next letter, U, very nice, N, D, they drifted around, that'll do, his clothes drifted around. And when he came back to Earth, the word that, how would you describe how they felt on his body, his clothes felt? P and A and I N F, all the way down, U, and his clothes felt painful, yes. Just the thing that made them feel painful was the weight of G, R, A, V, I, T, and Y. Yes, the weight of gravity. So, let's read a bit more. Since the year-long mission ended in 2016, Kelly has become a guinea pig for scientists studying what happens to the human body when it ventures beyond Earth's atmosphere. Even among astronauts, he's a rare case. Not only did he spend the best part of a year in orbit, but he has an identical brother. Oh, an identical twin. And he's called Mark. This gave NASA an unprecedented opportunity to study the physiological, molecular and cognitive effects of long-term spaceflight. So Scott went to space, Mark stayed on Earth. So Mark became, how would you describe Mark in this experiment? Mark, he, what? How would you describe him? He, P, R, okay, I'll take that as an R, O, V, I, D, good, E, D. He provided A, C, O, M, C-O-M, P, keep it going, come on, keep it going, A, R, after the R would be, touch the R again, R, next letter, I, a comparison, S, O, and after the O would be, yes, he provided a comparison. Because he was an identical twin, a comparison. It's a bit like in any experiment, if you want to look at the effects of something, then you have to look at maybe one group of people who do one thing, and then you have to have a control group who sort of carry on as normal, and then you're probably able to analyse the differences and the effects. So, the brothers are both retired astronauts now, but their contributions to the landmark twins study continue and have produced a wealth of information about how space affects the heart, the microbiome, the immune system, and more. Okay. One of the things that the study is looking at, how space affects the, just choose one of those for practice. M, I, C, very nice, R, O, B, micro. Now you've done the B, now let's see if you, touch the B again, B, then the I, O, M, and then microbiome. Very nicely done. And you did O, M, E. Holding the board yourself with me, just giving you a little bit of prompting. Right, when you think of the microbiome, what do you think about? Bring yourself back down. When you think about the microbiome, what do you think about? Well, S, T, O, M, A, C, H. Yeah, that's a good answer. Stomach. Or your gut. We talk about your gut. Bacteria, the microbiome in there. So, learning about the challenges of spending prolonged periods in microgravity is vital as space agencies and private companies get serious about sending humans back to the moon and even to Mars. Now then, if you were to travel to Mars, I wonder, I think we might have talked about before, how long do you think it might take to travel to Mars? What do you think? T, H, Okay, yeah, I think you're right. I think you remember. T-H. R. E. And the next letter. Go on. Ooh, little inch. And the next letter. After the E. Another one. You've done it. 3 months, weeks, years. What do you think? Y, yes. Y, just for practice. E, A, R, and touch the S. Touch it. Touch the S. Touch the S. Go on. Very nice. Good. 3 years. Yes. I think that was right. Let me see what it says here. Oh yes, there we are. Our mission to the Red Planet is potentially a 3-year trip, so we need to understand what might happen to anyone trying to make it. One of the scientists prodding and poking the Kelly brothers is Christopher E. Mason, the lead geneticist at Cornell University. His work centres on a 500-year plan for the survival of the human species on Earth, in space and on other planets. Oh my gosh. As well as studying what happens to astronauts, it involves laying the genetic groundwork for humans to live among the stars. So this isn't just about space travel, it's about L-I-F. Yes, it's not just about travel, it's about L-I-F. Touch the E. Touch it. E. It's about life. Yes, about life in space. Not just travel, but actually again to live in space or on other planets. My gosh, that is ambitious, isn't it? Oh look, there's a picture of the twins. Yeah, right. So he envisages a future in which the human genome can be bioengineered to adapt to almost any environment, augmented with genes from other species that allow us to explore and settle the furthest corners of the universe. Oh my gosh. Could you put that into your own words? H, E, T, H, I, N, T, H, I, touch the N again, N, now the next letter would be T, H, I, N, K, K, he thinks, he thinks, go on now, I, T, W, I, L, W, I, I'll take that as a double L. He thinks it will, go on, B, E, B, P, P, N wouldn't make sense, P, O would, yeah, P, O, go on, P, O, S, go on, S, I, B, finish the word, L, then E, he thinks, it will be possible. Go. You sat down for a while. T to A. After the A would be L T E R to alter H U M A human J G E G E come on. He thinks it will be possible to alter G E N O M E. Right, he thinks it will be possible to alter human genome. Yes. He says he envisages a future in which the human genome can be bioengineered to adapt to almost any environment and augmented with genes from other species. Goodness me. He is serious. He's written a new book, The Next 500 Years, and it maps out in detail how we'll do it. Oh, so his new book is called T-H-E-N. Let's just practice it. Hold it. N-E. That's good, that's the E. Now down to the X we want. Not the S, we want to go down to X. And then the T. That's S. Move over to the T. The next. The next. And then there were some numbers. Hold it again. 500. 5 and 0 and one more 0. Not 1, 0. Touch it. The next 500. And then we've got some letters again. Years. We want to start with the Y. Which hand do you want to point with? Hold with one hand and point with the other. The next 500. Now then. Okay. Now we want Y. Y, the bottom there. Okay, so you get drawn just to the where I've put tape on there. Let's try it flat. 500. Lean forward. Touch the Y. Y. Then up for the E. E. Next letter would be Y, E. All the way to the A. A. Let me hold it up a bit. R. Which letter? S. Yeah. The next 500 years. That's what his book is called. Good. This is good practice, Chris. You're doing ever so well. Right. It's 500 years in the future. Paint a picture of what it looks like. So 500 years from now we'll have two key things. I call these the twin engines of discovery. Oh, so two key things. Okay, let's have a look. The twin engines of discovery. Twin engines of discovery. Number 1 is a good list of candidate exoplanets to go to. Okay, so number 1, list of planets, we'll just say. In the past 10 years, thousands have been catalogued, including several hundred Goldilocks planets that are probably not too hot not too cold, and that we could possibly survive on. So we've already identified Goldilocks planets. I like that. So, why are they called Goldilocks planets? A F T E after T H E after the S T O R Y after the story A B. Oh, and don't swipe. A B. Touch the letter O U T about T H E the after the story about the P O P O R, yes, P O R R I after the I, go on, you're right. P, lift your elbow. I, keep that elbow lifted so you can move around the board. Touch the I again. I, D, doing so well. Go there, push, push, G, then after the story about the porridge, yes. She went to the Three Bears' house, didn't she? After the story, and the one bowl of porridge was too hot, one bowl of porridge was too cold, and one bowl of porridge, that was the baby bear's porridge, was just right. I like that analogy, yeah. So why was it Goldilocks? After the story about the porridge. We'll just do this little bit and then we'll take a break, okay? In the next 500 years, we'll have, I'm sure, thousands or tens of thousands of other candidates. We could use the intervening time to get better spectroscopy and imaging of the atmospheres to figure out what's there and then pick the best ones. I think we'll have to do what the other thing is. So we've done number 1, 2 key things, the twin engines of discovery. Number 1 was a list of possible planets. What's the other thing? Well, the second thing that will happen is that we'll discover a number of genes in the human genome and other genomes that we could use to regulate our health, design medical treatments, or engineer organisms that could survive a long space flight to another planet and survive on it. Oh, so discovery, so number 2 was discovery of genes to regulate health in space travel so that we could survive it. And it's not just for human cells. Microbiome cells, of course, would be engineered to produce products, as they do for us now, therapeutically. We'd have a genetic toolkit that will let us counteract the ill effects of long-term space travel and produce the things we need, like food and fuel. And obviously, the more genomes we have in our kit, the more tools we can make. There! So the second thing was to do with, just to finish, the second thing was to do with G-E-N-E, genes. The second thing was to do with genes. Yes. Okay, that's very good. We'll take a little break for now, because it's nearly lunchtime, And I think we'll look at this article some more tomorrow because it's very interesting, isn't it? Yeah, we can carry on with this session. Thank you, Chris. That was really good.